Paint a picture with me. Picture yourself, it's 4th of July, it's a hot summer day, and you're enjoying a fresh watermelon. Now let's change seasons. It's fall, leaves are changing colors, and you're having fun with friends while carving a pumpkin for Halloween. Well, I have bad news and good news for you. Crops such as watermelon and pumpkin are in danger, and also crops such as cucumber and squash. These crops are called cucurbits, and they're exposed every year to a pathogen that causes disease, reduces yield, and quality of the fruit, like you can see in the images here. In the upper left corner, we have a healthy cucumber leaf. The next picture shows a leaf with symptoms, and the last picture is what the disease eventually does to the fruit. This disease is cucurbit down and mildew. Currently, the disease is managed with weekly fungicide applications. These fungicide applications are more effective when they are applied preventatively. But how do we optimize the fungicide applications to have the most effective disease management? This is what my research is all about, and this is the good news. We can optimize fungicide applications if we know exactly when the disease gets to growers' fields. But how do we do that? With biosurveillance. Currently, growers know the disease arrives to their crops using scouting. They scout their fields for disease symptoms. The issue is, this is an airborne pathogen, so once you can visually detect the disease in your crops, it is likely too late. My research focuses on catching spores on a trap and taking those spores to the lab for a qPCR test. These tests will detect pathogen presence in the crops. Spores are basically just microscopic parts of the pathogen. Think of this as a COVID test, but instead of swabbing your nose for viral particles, we are basically swabbing the air for pathogen particles. By doing this, we can know exactly when the pathogen arrives at our field sites. But why is this information important? Well, think of the cycle of the crop. This is a very simple version of it. You have planting to your left and harvest to your right. Commonly, growers start applying fungicide 3 weeks after planting. Focus on the red line in the diagram. And they keep applying those fungicides weekly. But with the biosurveillance system we are designing, we have shown that we can detect the pathogen 6 days before you can visually confirm disease symptoms on the crops. And you can focus here on the orange and pink lines on the diagram. This means that growers could save all of this money in fungicide applications. This also means that they can be more sustainable with their fungicide use. And in the end, this will also allow us to keep enjoying watermelons in the sun and pumpkin carving in the fall. Thanks.